Hello everyone, my name is Walking Feng. Today I want to talk about history of the turbine flow meter. A turbine flow meter is used to measure fluid flow in pipe or open channel. Measuring that back to SM water conservation project and urban water supply system. Orified plates were used to measure water consumption in ancient Rome. Around 1000 BC, Egypt used wheel to measure the Nile's flow. The famous Tujiangyan Water Conservancy project in China used the aquarium mouth water level observation and so on. Daniel first manually, a Swiss scientist, used differential pressure to measure water flow in 1738. In 1791, Italian G.B. Venturi published his finding on the use of the Venturi tube to measure flow. In 1886, American Sheher applied the Venturi control to become a practical measuring device for the measuring water flow. The original measurement principle matured from the early to the middle of the 20th century. People stopped thinking about the original measurement method and began a new exploration. In the 1930s, the use of sound waves to measure liquid and the gas flow rate reappeared. Sound waves were not used to measure flow rate until the Second World War. Maxwell applied the sound cycle method in 1955. Flowmeters measure the flow of aviation fuel. After the 1960s, measuring instruments start to become more precise and smaller. Turbine flowmeters evolved alongside industrialized production. Today, with rapid industry development and intelligent digitization, we believe turbine flowmeter will be able to keep up. Thank you.
Hi Doctor, my name is Zhong Ji-yong and my metric number is 201110742. And now I'm going to talk about the working principles of turbine flow meter. The turbine flow meter has a relatively simple working principle compared to other flow meters on the market. Basically, the flow meter uses mechanical movement inside the meter to calculate the flow. The turbine flow meter has a rotor with blades mounted on a bearing and supported inside the meter by a central shaft. When we have a fluid flow inside the pipe, the kinetic energy of the fluid will make the rotor spin. The blades are built from a paramagnetic material, so pickups mounted externally without contact with the fluid create a magnetic field inside the pipe. Thus, when the blade pass through this field, they will generate a voltage proportional to the velocity of rotation, which can be used to calculate the flow rate. The signal from the pickups can go into an external transmitter and convert to other types of communication. And we can also use a preamplifier to read these pulses directly from the turbine flow meter without the transmitter. Now, my group member will continue the presentation. Thank you, Doctor.
Hi, Dr. Ajizu. I am Chinwei Xiang from Group A03. My trade number is 201112413, and I am going to talk about the advantages of turbine flow meter. One of the advantages of turbine flow meter is it have a relatively high accuracy comparing to other types of flow meters. For liquid turbine flow meter, the accuracy is generally plus minus 0.25% to plus minus 0.5%, while for gas turbine flow meter, it is generally plus minus 1.5%. Besides, turbine flow meter also has a wide measuring range. For large size turbine sensor, the turn-down ratio can be from 40:1 to 10:1, and for small size sensor tube, it can be 6:1 or 5:1. Turbine flow meter is suitable for high pressure measurement as well. The output pulse frequency signal of turbine flow meter also make it suitable for total metering and computer connection, as a very high frequency signal can be obtained from the turbine sensor. Various types of structure of turbine flow meter also let it available for various measurement purpose, such as made into tricam type for hygiene purpose. That's all. Thank you.
Good morning, Doctor. My name is Heng Jiayan and my matrix number is 201110751. So now I would like to present the disadvantage of turbine flow meters. First of all, there will be errors caused by high viscosity in samples. This is because viscosity have a great influence on a flow meter's performance. Since viscosity are closely related to temperature and pressure, in the case of large fluctuation in temperature and pressure in the field, compensation measures should be taken to maintain the high accuracy. Apart from that, frequent calibration checks needed in turbine flow meters. This is due to it is difficult to maintain the calibration characteristic for a long time, and it is necessary to periodically recalibrate. For non-lubricating liquids, when the liquids contain suspended solid or is corrosive, it is easy to cause problems such as bearing wear and rotor stuck. When high accuracy is needed, it requires to have on-site calibration equipment that can be calibrated regularly to maintain its accuracy. That's all for my part. Thank you.
Good day, everyone. My name is Vinod Sana Bhaskaran, and my matrix number is 211110777. Turbine flow meters are used to measure clean, dry gases and liquids such as hydrocarbons, chemicals, gases, vapors, fuels, and other types of fluid with lower viscosity. So turbine flow meters are now applied in many industries. So now I'm going to explain on the application in automotive industry and also the water treatment plant. So in automotive industry, the turbine flow meter are used to measure the flow of fuel, engine oil, coolants, transmission fluid to optimum the vehicle performance. So if you see in the water treatment plant, the turbine flow meters used to monitor the water chemicals levels used to treat the water during treatments in hydraulic fracturing. So if we see here, the water treatment includes delivering the right dose of additives, disinfectants, pH adjustment, corrosion inhibitors, and fluoride. So these additives are vital in disinfecting water to meet stringent safety guidelines. So the flow meters ensure the correct dosage is distributed to properly treat the water. So if you see here, this is the sample of flow meter that used in the water treatment plant. Okay. Thank you. Have a good day, everyone.